Okay, so um, to design the control layer, the first step is to clearly define the problem. So if you want to look at our end user stories and the UML, um, and try to divide. And the second step from that would be create the test metrics. And step 3 would be outline the solution. Step 4, we will have to test the algorithm. Step 5, translate the algorithm into code. Step 6, run the test cases to verify that the code is working as specified. And the last step, step 7, is to deploy the changes to the repository. Okay, so we have this example for the get weight function test metrics. So we have the inputs, valid inputs, invalid inputs, the boundaries, and our variables are pickles and eggs, and we would want to output the weight. So for the valid inputs, we put 20 for pickles and 12 for eggs. And we noted here that the egg weighs only half a pound. That's the reason why the output should be 26, because the egg is only half the pound. And we would have to put anything that would be the errors. So we have the error message too right here in the bottom to explain what type of errors they are. And invalid inputs we put for the first one would be having 101 for eggs. So the error message would show that you have too many eggs, which it's gonna output the -1 as an invalid. And for the second invalid, we have a negative number. So it says pickles cannot be negative, which our output should still be the -1. And the last invalid inputs that we try to put then now the negative for the eggs, because the last time was the pickles. And so we also have boundaries, and I'm guessing this is, I'm not sure where, oh, we have the boundaries between 0 and 100. So the 100 is maximum, 0 is the minimum for the boundaries. Okay, so creating the pseudo code, so the gateway function would be, we have to have as a public, and our data type is a double, even though unofficial pickles is integer, but double basically is it is bigger than integer. So we're using the if statement. Correct, yes, if statement. So if pickles is less than 0 or larger than 100, we would want to return the error code. And if eggs is less than 0 or larger than 100, we would also want to return the error code. And after the if statement, I think is the if else, or is it just return? I think it's just return, and the this.pickles concatenate this.eggs. That should be our code. Okay, yes. So basically, so that's why we have the at test 1, 2, 3, 4. So for the valid and the 3 invalids. And in this one, so we put the valid one. So for the pickles, total 20. The eggs we have to divide by half because it's half the pound. So the expected result should be 26. And let's see if we test this in 3. Run file. Are you guys ready, right? Run file.
I believe it was test file is what you're looking for.
Yes, test file.
It's 3 below
Oh,
run
yeah.
file. Yep.
So yeah, it says
Okay.
all 4 test time, because yeah, this one is the valid one, and you could tell it invalid, the 101, the eggs is basically more than 100, larger than 100. This one is the second invalid test would be with the negative for the pickles. There shouldn't be any negative number, or anything below 0, and the invalid number 3 is the one for the negative for the eggs, which shouldn't have any negative for the eggs either. Yeah, so basically, like, pretend like for the invalid test, so in a sense that because we're gonna have the which is the view layer, we have the end user, and they were to put something that even though we pull out the system that print line as the specified command, but if they kind of ended up putting for some reason something that's different from what within the calculation or the basically the amount, and it would give them the certain error messages and would like let them to maybe re-enter a valid one for the next time. So that way, well, in a sense that because it's the code, it's a program that should work well with the end user. We have this system that in, system that out to let them know whether or not they put the right or the valid things.
Okay. And also, I'll insert this. What we are doing here is we are basically verifying that our code was working and that it's not going to run into any parameters that we don't want it to. We have it set that there are certain maxes and minimums that we want our code to be entered into, and we don't want it going like over or under that, or we want the results to be as expected. We don't want it to result in something that we don't, was unexpected.
Yeah, to actually get the right calculation instead of not having any boundaries whatsoever.
Okay, excellent. So the function that I'm going to explain to you right now is the do loop. The do loop is basically a function that says always execute this whatever is inside of my parameters. And then it has a contingency to it. It basically says do it as long as, and then there's a parameter, or like I said, another contingency that it has to fulfill. In this case of our do loop, we have a while done is false. So we automatically set our done to false so that it's going to execute this loop. The loop is just a simple loop with an if statement inside of it right now, but then once it's done, we have to make it so, or we have to set the done statement to false so that it's actually going to continue, or it's actually going to execute and move on to the next part of the code.
Yeah, because it's while not done.
Exactly. So I'm just going to keep recording with my screen, so you can probably just look on my screen, Camden. You want to go ahead and explain the if statement that we have right here? Or do you want to explain the next one, which is the switch statement?
I mean, I can explain the switch statement if you would like me to.
Do you want me to explain Q?
The quit one?
Yeah.
Okay, so the do loop continues to run until someone enters in Q, and then once Q is entered, it then runs a return, which then ends the execution of the program.
Okay, and what is the purpose of having it inside of an if statement? What do if statements do?
Just there it is.
So it's in an if statement, so that way if it happens in any instance as the loop is running, if it ever detects it, then if it happens, then it'll run the code for the if statement and cut out the rest of the loop.
Okay, very good. So Maricela, you want to go ahead and explain this switch statement that I have on my screen?
Yes. So within the do action, so if the end user did not type Q, and it goes on to the do action function. So we put that so we have to put the choice that to uppercase, just in case the end user basically type lowercase instead of uppercase, and then we assign that to the variable named choice, and within the switch, we have, which is I think that parenthesis it's called is a condition, right?
Uh-huh.
Yeah, because the switch. I mean, no, within the parentheses, not condition is expression. So the expression is that a variable name choice. And for switch statement, you would want to have cases. So and right after the cases, it would be basically the constant or something with it under inside the parentheses. So if someone types n, which that's why like it's capitalized N because we have the choice that to uppercase, and it will give this that start new game. So the N, the letter N, it would be for start new game, and we would want to have to put break just so then it doesn't gives this the second case because without the break it would the program would print out also case the second case or whatever case until there's actually a break. So we would want to put break for each cases, and then we have the case Q, and that's the existing game. Start existing game. For no, that's not Q, that's a G. And then there's age for display, the help menu, and we have is that save game, the S for the save game. And we would have to have a default. Well, I mean it's not so it's optional. The default is optional, but we would put the system.out print line and would put down the basic statement saying invalid selection, try again. The default is just one if the end user were to put a wrong letter or any other letter beside the N, the G, H, and S. And we also after that after the closing bracket right there, we would have to have the return false.
Okay. And if I might expand a little bit on this, basically this switch statement is kind of like a do loop. It basically says do something in a certain case.
Yeah.
So in this case, if N is typed in, it's basically saying then go ahead and execute what I've told you to, or do what I've told you to, which is, in this case, fetching the function, or, not fetching, but anyways, connecting with the function start new game. And then it breaks, because if it doesn't break, it's going to cause an infinite loop.
Yeah, exactly.
It's going to continue to do it until we tell it to wait and receive more instructions.
And which class did you want it to do?
I'll go ahead and do the pace test.
Okay.
Okay, so what we have going on right here is our test cases, or our test units for the pace control test. Now the pace sets the pace at which our team members will be moving. There's going to be a consequence if they're moving too fast. There's going to be kind of consequences if they're moving too slow as well, because it makes the game last longer and they end up using more resources. So the pace in this case has only 3 different variables that it can be set to, which is 1, 2, or 3. That is slow, medium, or fast is what it's set to. Now inside of the pace control, the reason why we have our test instances the way that we do is we have it set to 0 because we don't want anything lower than 1, 2, or 3 being set into there.
Okay.
And we don't want anything higher than 1, 2, or 3 being set into there. So 4 is also one of our expected results to fail. We want to see a fail on that if that happens. But in this case, with the pace 2, we want to see the expected result to be 2. We don't want a failure, which is our -1. We want an actual credible output for this, which will then just continue on with the game. So we'll go ahead and run a quick test here just to show you how that it is working. And we can see that we passed all 3 tests that we have right here for the get pace. That it did fail on the ones where we wanted it to fail, but it also passed where we wanted it to pass.
So for this test matrix, we are testing to see if the amount of people is within the bounds that we've created. So the maximum that we're allowed to have is 40, and so in the test, or in the function, it adds the, in this first test instance, male with 35, and then there's 5 females. It adds those together, and you get 40. And that's our expected result. And so as it equals 40, then the test comes out positive. In this second instance, with test get number of people number 1, the number of people is over, it's 41, where it does add and add up from the males and the females to that number, but because that is an unallowed number, it's over the 40, the result is then a false. And so if we were to run those, we can, if we were to run those tests, then we would be able to see those expected results come out.
Okay.
Yeah,
Shall we go ahead and run them?
Yeah. Or test them.
Oh, that's
Running.
right.
Yeah. And so as you can see, all of them pass with the expected results, and show that the function is working correctly.
Okay. Excellent.
Yeah. So then after that, the two of you can show the scope and the lifespan, so we could divide in that. The scope, the definition of scope is that it specifies where a variable can be used or referenced, and the scope of a variable is confined to the block that the variable is defined within. And the definition for lifespan is when a variable can be used, and a variable's life begins when the variable is defined and ends when the execution leaves the block the variable is defined within. And maybe Devin, you want to show probably the scope of it, and then
Yeah.
Camden could show the other one.
I'll go ahead and explain the scope.
The last.
Right here you can see in our public class help menu view function, we have different variables that are declared up here in the beginning. They are all private, and they are range from objects and strings to booleans.
That's the data type.
Yes. And what that is the block that it is contained within is going to be this block all the way down until the block executes. Now there's different cases in which sometimes you will instantiate a variable inside of just one function. Kind of like this done one is, even though we have it specified up here, it is also technically specified down here as well. And this variable exists in the memory of the computer until we are done here, ironically. And once it's done, it would execute, and it wouldn't need that variable anymore. It would go ahead and throw that away and take it out of its memory because it doesn't need to use it anymore. The other ones that we have are like our object choice and our string menu option and string values, which are going to be called later on in our code, but it's only going to be in this section of our code. It's not going to go outside of it because it would be outside of the scope.
Yep.
Okay, so the other part was the lifespan of a variable.
Yeah.
I kind of explained that as well, but Camden, why don't you go ahead and explain the lifespan of a variable? Is there anyone you want me to highlight in particular over here, like maybe the choice variable or the done one, or do you want me to go into the inventory layer and you can do the inventory class?
We can stay on the help menu view.
Help menu view? Okay.
Yeah. The lifespan of a choice is that it's within that function, and it'll stay only within that function, and then once the function's done running, then it's erased. It's no longer used. It's gone. Correct?
Yeah.
Yes.
They technically have an ID code within the I don't know, the data in the memory, which is then that is passed by reference. Those things are passed by reference to whatever they're called. But then passing by value is more of like the value within that variable that's created.
Yeah, so basically primitive passed by value is the actual value of a primitive that is passed and copied. An object passed by reference is the location of the object, and memory is passed and copied.
Yeah.
Okay, yeah. And here's actually a good example that we have right here in the point control class. We have a function, but this function has two parameters within it, which is integer x and integer y. Now it's going to assign each one of these to the next thing that comes up, which is going to, or which, whatever we set our variable equal to, which is going, in this case, our x coordinate is equal to integer x, and then our y coordinate is equal to integer y. So that's what's setting up how the parameters are connecting to the values that we have set up inside of our function here. I think actually with what we just said right there, that might be good.
Mm-hmm.
Yeah.
Do you want to like also show the object part, like when we create a new object?
Where would be a good example of that?
I think we had it in the test one, the test packages, like maybe even the main menu, because I think we had created a new object called what was it, like to start a new game? I guess it's like create new game. Yeah, because the new game menu view.
Yeah.
We assigned the variable to the menu.
Well, what this is and what it's doing here is it's a function. And the function that we gave it is the name of start new game. But within this, we are calling to a different class. The class that we're calling to in this case is the game control, and inside of that, we're calling to a different, I believe it's package is the game control.
Yes.
And then it's the class that we're calling to is the create new game. Now inside of that, we basically want to make this create new game class into an object so that we can use it and actually execute it. And how we do that is exactly what we've done down here, is we've turned our game menu into a new object that we're able to execute and actually use in our code.
So that data type would be the same thing as the one we put on the right, because there's a rule to that. Because the game menu view function, we assign it to that variable named game menu, and the data type of that game menu variable will be the game menu view.
Yeah.
That's how to create an object.
And it's part of object-oriented programming that you have to create the object or turn a class into an object in order to actually execute it, in order to actually go in and have it occur. Otherwise, it's just kind of taking up space in the computer's memory and it's not actually being activated.
Yeah.
Yeah.